I'm going to demonstrate how to get insights from the dataset. I choose the dataset from Kaggle, Breast Cancer Dataset, so we can explore that what data it has. So this is all the columns. So and we have malignant or benign. So malignant is a cancerous and benign is non-cancerous diagnosis. So we can download this data. So press on download. When you get the download, it's gonna get a zip file. Just save it on your computer. When you open it, and just drag this dataset to your desktop. And after that, you can import data to RapidMiner. Just go try to find this dataset and find where you want to save it. So, for example, like go to project data. So, and now we can bring this dataset into our process and explore it. So if we go to statistics first, we check if there are any missing values. So none of the columns have missing values. Most of them is just some kind of measurement and numerical values. The diagnosis we're going to predict, it has only two types of values, M and B. And ID we can pretty much remove because it's not going to make any, it doesn't have anything for our models. So first of all, I'm going to set a role. And I just drop it here. I can remove this. And here I'm setting role to diagnosis, and the role will be labeled. And I also want to select attributes, and I'm going to exclude one attribute, and I'm going to exclude ID. Yeah, ID here. We can check what we got now. So we have green, it's what we're going to predict, that here is no ID. ID is gone. So now I'm going to split data for training and testing. And one will be 0.7, and another will be 0.3. And now I'm going to run logistic regression. Logistic regression is good if you have only two things like yes, no, or like here it's cancerous, non-cancerous. And after that, we also want to apply model. When we apply model, first we say which model and to which data set. And then we need to see the performance. We bring performance here. Sorry. So lab goes to lab, and performance goes here. Now we can run and see. So it predicts pretty well, 89% and 94% here, and accuracy of this model is 92.4%. Okay. If we going back to the design, what we can do now, we can disable this operator, remove it, we can completely delete it. What we can do, we can try another model, for example, random forest. We bring random forest, we give the data set for training, and then we apply model. And like this, you just swap the models. Here, it also gives pretty good result, and accuracy already 95, 91, which is 3% better than previous one. We also can disable this one, and you can try neural net. Again, we connect the training data set and model with model, and let's check this. And this accuracy is 96%, 96.49%, which is pretty good, and it's predicted through 100%, which is very good. So now I can actually increase its performance. To increase performance, I'm going to disable all of these four and just move them away. You can delete them. So the next thing I'm going to do, I can add a forward selection. I connect here, double click. Inside, I put cross validation. We're going to connect, double click. So, and here we have to apply to put our model. So the best model we had was neural net. So it will be training and it will be the output. So now we need to apply model. So we get the model from here, but and testing data also comes from there. So in the cross validation, it splits dataset to 10 parts, and it starts training on 9 parts, and 1 part comes as a testing. And like this, it's in every iteration, it's just changing. If first checking, testing on the part number 10, then on part number 9, then on part number 8, on all of them. And after that, we need to check the performance. Well, we do this because now we can train on all the data what we have at the moment to see the better outcome. So now performance connects to performance. We're going back to forward selection. And in forward selection, we need to get the performance out. And in the process, we have to connect performance with result. And we also can check attribute with result. Let's run it. It's going to take some time because it pretty much makes data 10 times bigger than it was before, and does 10 iterations through the data set. I will pause video. So now this model finished running and we can check results. So this is the attribute weight. If it has 0, it doesn't actually have much influence on the result, but we can sort it. And each attribute which has number 1 value, it means these numbers actually have an impact on the outcome of the model. And we can check the performance, and currently it gives 98.25% accuracy from previous 96.49, so it's added like nearly 2%.